Alright, so here we go. Essentially, I've recorded this video a dozen times, or, coming up on it, because of either it recorded properly and there were some silly, problems, or dogs barking or whatever. Or there were comp.is making my desktop flicker problems. So I didn't think it'd be good to upload something that's flickering. Anyway, so yeah. The Linux box is still booting. We can cover the Windows box now. We can see that I have three command shells open, and that one of them has focus. It's critical that that one has focus because we'll be using it momentarily. And I did this by selecting in startup to have only the one that I needed to have focused in my particular startup folder. The other two are in all users. That's because all users is launched previous to a particular user logon folder. And there are the other two. And what are they? They are Netcat listeners on ports 8008 through 8010. They have command shells attached to the Netcat listener. And that covers that part. Let's see, I use AutoIT quite a bit in the tutorial. And essentially it's so that I can launch Immunity Debugger on a remote computer. Run is the launching. When active is the regex for the title bar. Send key delay is how long it should take in between keystrokes. Send is sending the keys, or sending keystrokes. Let's see, that's that, yeah. And then we sleep for a while before we tell the application to run. So that's pretty much it for those. You can compile them, which is useful, and that turns them into executables that I dropped on my desktop. So that's how that works, essentially. I had some issues with getting them to launch properly, because evidently it requires something with the inputs and outputs that wasn't functioning properly. So I created these batch files to launch them and then launch netstat, because evidently that fixes the problem with inputs and outputs. If you're working through it yourself, and you try it the other way, you'll understand. I tried it with Servify This, but it launches the respawning listener as system and doesn't let you create windows and interact with them, even if you use run as commands. So this is how I had to do it. I hope that makes sense to everybody. If it doesn't, try it the other way, and after you're done, beating your head into the wall for hours, you can do it this way, and it'll just work. And this is our Ubuntu fuzzing box. Alright, we've got a new dump and an old dump. And I haven't sorted out all the bugs in the script yet. So if it's a little buggy, that's to be expected. There's going to be another another component to the tutorial where we make it actually do the binary diffing, and where we make it actually do the where we sort out most of the bugs. So the Ruby connector will be covered shortly, and let's go take a look at the Python component. Let's not do it that way. Let's do it this way. Alright. The Python plugin that I wrote is bindiff. Bindump would probably have been more accurate, but I import a bunch of the immunity libraries. I import socket because I connect back to my Linux box with this computer and just shovel all of the addresses and assembly instructions back to my other VM so that I can play with it there. And essentially this is global declarations, the usage script or usage guidelines, and then we get into declaring that debugger is a local variable. That's a component of some of the scripts I ripped. It doesn't need to be in here. Then we parse command line. We parse arguments. Then we parse. Then we try and open the socket, and then we get the module name from the environment variable. Then we walk the functions for the module. Then we give the starting and ending address, assembly, contents of each basic block within the function. Okay, give me a second. We do the function start address, the basic block start address, and then the basic block instructions in assembly, and the basic block ending address, and then the end of the function address will be there eventually. So yeah, there's still some things to be worked out, and the mark end is used in conjunction with the mark begin to determine how long it took us to run this component of the script, and we dump that on the socket and on the log, and this tells our socket that it's finished. I use the exclamation point as a end of line delimiter in this particular case. Alright, let's explain the code. Those are empty functions that I haven't implemented yet. Some of the functionalities are already implemented, but they're already in this huge just chunk of garbage that I've put together in Ruby, and I'll turn them into functions and possibly classes at some point before I turn out the next video. Now we've got the some string declarations. We create our connection to the Windows box. Create some strings. Create a new file that's a placeholder in case in case some other routine doesn't have the ability to see the file, and we do it as a global. We create a TCP server, and then while we are for each connection that we accept, we set a couple of strings to blank. We try and determine if files exist so that we know which ones to use. And then we start our string parsing loops, and I use exit as the end of string, delimiter, and then bang as the end of line delimiter, and then we just append whatever strings Python sends us to one big string. We replace new lines and carriage returns with empty, and then we go back and replace the bang character with a new line. That way it simplifies data parsing. We create an all, we add to an all functions string itself and the currently received string. Now we notify the user that we did that, and if we have an exit command within the parse data, if we don't have an exit string within the parse data, we reset the string. Otherwise, we write the string to a file and close the socket, and then we restart the loop. I was having some trouble parsing for exit at one point or another, so that's what this was about. I could delete that now. And then we close the socket. That's the end of the thread. And now we start our new, we start our other concurrent loop with, as long as we don't have quit, we keep bang quit, we keep running. We read a line. If the command's not equal to a new line, I was looking at stripping new lines, I decided against it. If the command equals restart or R, then we restart the other thread. If the command equals load A, then we send a couple of new lines to the netcat listener. We wait for it to give us back a greater than symbol. It'll be the end of the command prompt. Then we send the command to launch the batch file, and we wait for 5 seconds. Same thing with load B, different batch file. This is a when we do the read line, if we get a con new line, we create a new socket to connect to the debugger and connect, and then the clean command deletes the old files. Something to note: if you only have one or the other, it will crash because I didn't handle the exceptions properly there. We do the ls is a command to just list the local directory. Not the local directory, but the directory that I expect it to be in. All the directories are coded statically. I'll turn them into variables eventually. If it's not bang quit, send it, and it didn't match any of the previous, send it as a command to the debugger. If it is bang quit, make sure that we actually quit, and kill the yeah, if it is bang quit, then send it. Okay, yeah. And then we can kill the thread, exit the thread, and delete the placeholder file. So that's a basic explanation of what it's doing, and if I could type, we launch our Ruby script, and we make sure we don't have the dump files already here, and then we load Immunity Debugger. It does its thing. That's what it looks like while it loads, courtesy of the AutoIT scripts. It launches, and the DLL loader didn't pick up the run for whatever reason. I need to increase the wait time. That's what it is. I need to increase the wait time on loading the thing. So anyway, it works fine when I'm not doing screencasting, but because I've got VMs running and screencasting, and I don't have a lot of RAM and a whole lot of other things, then it makes it run a bit slower, and I could increase my wait time to send the F9 run command to get us to this point. I've already recorded the video a half dozen times, and I don't think I'm going to do it again, so that's why I just hit play instead. So yeah, now that that's loaded and the module is running, we can connect. That's what that is. Then we can do a bin diff input file font sub and it'll take some time to run. And that worked. You can see that I used beginning line delimiters here to make it easier for me to parse. And then we can do a then we can do a quit to get rid of the immunity debugger. Then we can do a load B. Again, it'll do its thing, just like it did last time. And this time my wait was long enough. I don't know why I lagged a little more last time, but either way. That's one of the problems with scripting, and you have to tune your scripts appropriately. Now we can do the connect again, the bin diff. If I could type, I'm sucking tonight. Anyway, maybe it's because it's my, half dozenth time through the video. And then we dump it again. And it tells us that we're using the new dump file name, and it spits all of our assembly commands at us. I may have a problem in my current string parsing for end of line. I may not. We'll sort that out in the next video, where we actually do the bin diffs. But I thought this one was quite long enough as it was. Yeah. We tell that to quit, and then we tell our local application to quit. You may be asking yourself, why does he have secondary and failsafe? Secondary is so that I can connect on a different telnet, on a different netcat listener, so that I can restart the initial process. And failsafe is so that if both the secondary and primary fail, I can reboot the computer, and then all three will automatically respawn, and everything will just start working again. So that's what those are about. So we covered the immunity Python extension. We covered the AutoIT files, compiling to executables. We didn't actually do the compiling to executables, but it's a simple right-click compile script. We did look at what the stuff in the AutoIT file meant. We did look at the batch file meaning and why netstat A is there. It's because it causes this to release input and output. It's an oddity with using netcat, and the way that I'm doing this is really trying to string together a lot of tools to do a very simple thing. And we looked at the startup folders, and that's it on the Windows side. We'll turn that off. And we looked at over on the Linux side, we looked at the file. There was a clear function that deleted the immunity dump files, but there's a lot of code cleanup to do, and we'll cover some more in-depth stuff on in the remainder of the videos for this episode. And we'll also we'll cover the actual bin diffing and some of the code cleanup. So yeah, thank you for listening, and feel free to comment.